Hello everyone. In this video we're going to be solving an interesting exponential, maybe logarithmic equation, maybe both. We have 3 to the power log x with base 27 equals 4, and we're going to be solving for x values. I'll be presenting two methods, and here's the first one. So for my first method, I'm going to log both sides with base 3. And that kind of makes sense for two reasons. First of all, we have a base of 3 here, and the base for our log is also a power of 3. So you could also ln both sides, which is not going to be very much different, but I'm just going to use base 3. So log both sides and use properties of logs. So the base is 3. Now properties of logs tells us that we can go ahead and move this power to the front. Let's go ahead and do it. And when we do, we're going to multiply it by log 3 with base 3, which is 1. So we don't have to worry about it. So the answer is going to be log x with base 27. You could also get the same answer by just using the definition of logarithms. The exponent becomes the result, so on and so forth. And this equals log 4 with base 3. Okay, we have this type of equation and we need to solve for x. There's a few ways to proceed at this point. So I'm going to show you 3 alternatives. This is still the first method, but I'm just going to kind of give you like 1a, 1b, and 1c to get to the answer. Okay, so let's look at 1a first. So 1a is going to be using a hopefully well-known property. If you have log b with base a, that could actually be written as log b to the power n base a to the power n. So in other words, if you raise these two numbers a and b to the same power, then they just cancel out. And you can easily prove that by using change of base. So from here, basically, I can write log 24 with base 3 as log 3 cubed base with 24 cubed. And as you know, this is equal to log 2764 or log 64 with base 27. But guess what? This is equivalent to log x with base 27. And now we found that this is the same as this, right? And from here, actually, that shouldn't be a 24. That should be a 4, not a 24. Okay, I don't think 24 cubed is 64. I messed up. Sorry about that. So it's going to be 4 cubed, and that is 64. Notice that log x with base 27 is equal to this, which is this. So I can now write it as log 64 with base 27. Now what do you notice? The bases are equal. So when the bases are equal, the arguments, the numbers are also equal. From here you get x equals 64. Nice. That is the 1a. 1b. So we have log x with base 27. I'm going to use change of base. Let's go ahead and write it as ln x over ln 27. You can use any base, but I just wanted to convert it to this. And then we can do the same thing for log 4 with base 3, which can be written as ln 4 over ln 3. And guess what? These two things are equal. So let's go ahead and set them equal to each other. ln x over ln 27 is the same as ln 4 over ln 3. And now we're going to cross multiply. Let's do it. That gives us ln x times ln 3 equals ln 27 times ln 4. Now 27 is 3 to the third power, so let's go ahead and write it as ln 3 to the third times ln 4. Now you can definitely move this 3 to the front. That's going to give you 3 ln 3 times ln 4, and that's equal to ln x times ln 3. And from here, basically, right, you're going to go ahead and cancel out the ln 3. You're going to end up with ln x equals 3 ln 4. But 3 ln 4 can be written as ln 4 to the third power because of the power rule, which you can use it backwards too. And from here, x becomes 4 cubed or 64 as before. So that's going to be our second part or second approach for the first method. So it's kind of like 1b. Okay, great. So we got the same answer. And what about 1c? So again, we are trying to solve the equation log x with base 27 equals log 4 with base 3. Now this time I'm going to use the definition of logarithms. And here's how it works. We start here with the base. And then we go across and use this as an exponent. That's going to be our exponent. And this is going to be the result. So we have to come back here. So here's how it goes. 27 to the power, that is my exponent, log 4 with base 3, and that should equal x, this number. Okay? This is going to be the result of exponentiation because of definition of logs. Okay, so what am I going to do with this? Well, you can write the 27 as 3 to the third power, right? So that is 3 to the third power to the power log 4 with base 3. And then you can kind of multiply these two together. 3 to the power 3 times log 4 with base 3. And then move the 3 again. 3 to the power log 64 with base 3. When these two are equal, that's another rule of logarithms, we get the answer as 64. So this is x, so x equals 64 automatically follows here from properties of logarithms. As you can see, we are using different sub approaches, but we're always getting the same answer. So there's obviously a lot of different ways to go about it, and they prove each other, obviously. Like, how do you prove this property? Usually you can use change of base. How do you use the first one? Again, you can use change of base. That's why part B is talking about change of base, which pretty much explains everything. Make sense? Great. Let's go ahead and take a look at the second method. I hope this first method made sense real quick. First method basically involves logging both sides with base 3 and then solving the resulting equation, which is actually this one. Okay? So this is the equation I've been trying to solve, and we got the answer. So let's go ahead and take a look at the second method. Hopefully you'll like the second method better, I think. All right, so it's kind of like a wiser approach. It's less brute forcey. So we have, so let's rewrite the problem. Okay, so we're trying to evaluate 3 to the power log x with base 27 equals 4. So we're trying to evaluate x from here, or solving for x, I should rather say. So how do you solve for x? Here's what we're going to do. We're going to use substitution. Obviously, substitution is very powerful. I'm hoping you'll agree. So let's go ahead and take the exponent. Let's call that something. How about calling log x t? T is fun, right? I mean, t is cool. And then by using definition of logs, this becomes x equals 27 to the power t. So if you have any equation like logarithmic, you can turn it into exponential. If you have anything exponential, you can turn it into logarithmic. It works both ways. All right? Now, this is what I have for x, and I'm trying to find x, remember? But at the same time, I do know that from my assumption, because I call this t, right? 3 to the power t is 4. Great. That's just another consequence of what my assumption. But what am I trying to do? I have 3 to the 4th power is 4, and x is 27 to the power t. So 3 to the power t is 4, but I'm trying to find 27 to the power t. So I can write it as 3 to the power 3 to the power t, and then this becomes 3 to the power 3t, and then this can be written as 3 to the power t to the 3rd power. In other words, a to the power x to the power y is the same as a to the power y to the power x, because they're both equal to a to the power xy. Make sense? I hope it does. And since 3 to the power t is 3, this is gonna become, since 3 to the power t is 4, this is just going to become 4 cubed. And then from here, we're going to get x equals 64. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.